Okay, this last example, I want to talk about a property of proportions. So it's called the cross product, okay, principle of for proportions. So first of all, what is a proportion? And I'm looking on page 357, again, if you'd like to read a little bit more about it. And actually, let me go ahead and write sometimes. So cross products, product in mathematics means multiplication. So multiplication, and the reason I write multiplication is because you might have seen this principle called the cross multiplication principle. And I really want to talk about this because there's a very common misconception with using this cross multiplication or cross product principle. Okay, so what is a proportion? Well, a proportion involves fractions, and it basically says that two fractions are equal to each other, or ratios are equal to each other. So we've talked about ratios, right, or rational numbers. For example, so this class, so I'm counting people who actually come to class and have scores and not zeros. So for example, there are four males in this class who show up and are doing what are taking tests and doing ICAs and so forth, and there are 12 females. So we can say we can construct a ratio, right, from women to men, or from females to males, or males to females. So I'll just say, females to males, just to pick one. And females to males. And so females to males, well, there's 12 females over 4 males. Okay, if we actually reduce this, right, 4 goes into 12 3 times, or if you want to do the prime factorization, right, you're going to end up with 3, or 3 over 1. So we can say that another way of expressing this is sometimes we say 3 to 1, right? The ratio is 3 to 1, which means, in this case, right, there's 12 females and 4 males. You can also say the ratio is 1 to 3, right, and put males in the numerator and females in the denominator. So, I mean, you just have to be consistent and choose where you're going to put your females and males. Okay, so that, I mean, we've talked about ratios. So again, a proportion is just when two ratios are equal. So this cross multiplication principle says if I have A over B, right, equals C over D, right, and it can represent right there. Here's my A over B, right, here's my C over D, right, those fractions are equivalent. So if I have this, then I'm allowed to rewrite my proportion, right? I'm going to cross and I'm going to multiply. So here's A times D. So I'm going to cross and I'm actually going to multiply. And so I'm going to get A times D equals, and then B times C. And I mean, if you want to technically write DA, and CB, it doesn't matter. 2 times 3 is 3 times 2. So we're allowed to write this, which is nice because it clears the fractions. Now, whoops. Now, one thing I want to say is a very common misconception. Okay, cross this is important. Oh gosh, let me write this in red. Important. Cross, let me go back to white. Okay, I'll abbreviate. Cross multiplication principle or property. Okay, it only works with proportions, meaning if I have an A over B equals C over D, if I have an equation, I can do this, okay? You can't do this, right? So this is a bad or wrong, however you want to say it. Okay, if you have two fractions and you're multiplying them, okay, a lot of students want to do, I see fractions, I can cross and multiply, and AD times over BC. Okay, this is wrong. Cross multiplication has nothing to do, right? Has nothing to do with multiplication of fractions. Okay, that's the just common mistake. It has nothing to do with multiplying fractions, right? I mean, we're dealing with fractions, right? Here's a fraction, here's a fraction, and they're equal to each other, but it has nothing to do with multiplying fractions. And I know it can get confusing because you see cross and multiply, and you want to cross and multiply, but again, has nothing to do with that. So please be careful as you're working with this principle. It only works when you have two fractions that are equal to each other. So I want to do an example in the exercises, because you'll have it on your ICA really quick, on constructing proportions, okay? Because you really use this a lot in life. If you cook a lot, I mean, you use this for recipes. So let's just do an example. I'm going to do number 110. So in your book, 110 says the number of gallons of water used when taking a shower is proportional to the time in the shower. Okay, when they tell you something is proportional to something else, so in this case, we're talking about, okay, so number of gallons, let's abbreviate here, of water. Okay, of course, when you take a shower, is, I abbreviate this, is proportional to what? So they're talking about this quantity, and it's proportional to the time in the shower. Okay, so time in the shower. Okay, when you see this word proportional, if the number of gallons of water is proportional to the time in the shower, that means that the longer that you are in the shower, the more gallons of water you're going to use, right? I mean, you're more time, the water is running, so you're going to use more gallons. So proportional means the more you increase, right? The more you increase, if your time is increased, then these number of gallons are going to be increased. And we're going to talk, again, as we go on, we're going to keep seeing this word proportional. But let's construct the proportion. So again, the goal is to construct a proportion, and again, it's going to be some A over B equals C over D. So they tell us, okay, a shower lasting 5 minutes uses 30 gallons of water. Okay, so we're talking about minutes and gallons. I'm just going to put, again, it doesn't matter. I'm going to put the minutes above, so I'm going to do minutes to gallons of water. If you want to do gallons to minutes, that's perfectly fine. So 5 minutes in the shower uses 30 gallons of water. Okay, that's what's given, right? We have there's a ratio, so we're just missing this part. It says the question is how much water is used in the shower lasting 11 minutes. Well, they tell us that we're taking a shower and we're going to be in there for 11 minutes. So, I mean, minutes is on the top, so I'm going to put minutes there. And how much water, how many gallons? We don't know, so that's what I'm going to call X. Okay, X is like my question mark. So again, the construction's not too bad. Here is our proportion. So again, writing this again, proportion. So I can definitely cross multiply. So, right, cross and multiply, and set them equal to each other. So I have 5 times X equals 30 times 11. If you write 30 times 11 on the left and 5x on the right, that's fine. It shouldn't matter. So then we're just gonna multiply this out, right? I mean, your calculator, you can do 13 times 11. You're allowed to do that. So 13 times 11 is 10 is 300, should be 330. And I get 5x. And then 5, here we're using the multiplicative property of equality, right? Or 5 times what number is 330? Well, again, if you want to use that idea or not, again, optional. Just giving you options here because everybody does it differently. So I'm going to multiply by a fifth, okay? I'm really multiplying by a fifth, right? When you divide by 5, there's my 1x, so 1 times x is x. And then if you take 330 and you divide it into 5, you get 66. Okay, so x is 66. Well, 66 what? What were we looking for? We're 66 minutes? Nope. It's gallons. And it makes sense, right? If I take a 5-minute shower, I'm going to use 30 gallons. If I take an 11-minute shower, well, this is more, a little bit, it's like double, right? Just a little bit more. But double would be 60, so, a little bit more would be, 1 more minute would be a little bit more than 60, so 66 gallons, right, of water used. So that is your final answer. And that's pretty much it. So that's what a proportion is, and you'll have a few examples on your ICA. So make sure you're comfortable with this.